This is the what is this? No, this is the review that was on part of our assignment from Thursday, November 29th. So we talked about the left half of the assignment was dealing with the Triangle Inequality Theorem, and then the right half had review questions. On the video for that assignment, I went through half of this, but I ran out of time, so I was unable to finish all of this. So I'm going to do this again, just so we have these review questions all in the same spot. So this was from the second half of the assignment. That was the Triangle Inequality Theorem worksheet that we did in class on Thursday, November 29th. Okay, first question is asking us, it's telling us to assume that AB is congruent to CD. So the first thing we do when we see that is we should put the marks in. So AB is congruent to CD, and BC is congruent to DE. What additional information would you need in order to prove that triangle ABC is congruent to triangle CDE by side, side, side? So the side, side, side postulate tells us that if we have three pairs of congruent sides, so three corresponding sides of the two triangles that are congruent, right? Then we know the two triangles are congruent. So in order to prove that these triangles are congruent, we need AB to be congruent to CD, BC to be congruent to DE, and then we would need AC to be congruent to CE. So we need to show that AC was congruent to CE. So I mean, that's what it's asking. What additional information would we need? The additional information we would need is we would need to know that AC is congruent to EC. Okay. Or CE, rather. Both would be fine for me, but CE is the better way to go because they're going the same order, same way. You could also say, if you wanted to, C was the midpoint. So C is the midpoint of AE, right? Or C, point C bisects AE, or BC bisects AE, or DC bisects AE. Anything that would lead us to the conclusion that AC is congruent to CE would allow us to conclude that these two triangles are congruent by side, side, side. Three pairs of congruent sides, three corresponding sides that are congruent between the two triangles. Using the same diagram for the next one, they're telling us that AB is congruent to CD, and BC is congruent to DE, so same thing. What additional information would we need to prove that triangle ABC is congruent to triangle CDE by the side angle side postulate? So the side angle side postulate says if we have two pairs of congruent sides and the angle between them, the included angle, is congruent, then the triangles are congruent by side angle side. So we need two pairs of sides that are congruent, and the included angle needs to be congruent. The included angle is the angle between the two sides, the place where they meet, right? The two sides are going to form the sides of the angle. The two sides are going to form the sides of the included angle. So in this case, our included angle is going to be B, angle B and angle D, right? There's two sides, two pairs of congruent sides. Here's the angle that's between them, right? These are the two sides of the angle B. These are the two sides of the angle D. Angle B and D are between the two pairs of congruent sides. Okay, so that's what we would need to know, that angle B was congruent to angle D. Okay, because then we have side, angle, side. Side, angle, side. Okay. Right, if we did the other angle, so say we said, instead of these two, we said down here, right? We don't have any three congruent parts in a row. This would be angle, side, side, and we don't have angle, side, side. Okay, if we did this angle, right? Again, angle, side, side, or side, side angle, and we don't have those postulates. So in order for it to be side angle side, we need the included angle, the angle between the two sides. Triangle CDE is congruent to triangle FGH. And we know the measure of angle G is x plus 17. The measure of angle E is 19 minus x. The measure of angle H is 27 minus 2x. The distance between G and H, right, GH, is 39 minus 3x. They want us to find DE. Okay. First thing you should do, right, if we don't automatically see what to do, is draw our triangles. So let's draw triangle CDE. CDE. Okay, and triangle FGH. Okay, we know these triangles are congruent, so CD is congruent to FG, DE is congruent to GH, and CE is congruent to FH. Okay, we know angle C is congruent to angle F. Angle D is congruent to angle G. And angle E is congruent to angle H. Okay, we know the measure of angle G is x plus 17. We know the measure of angle E is 19 minus x. We know the measure of angle H is 27 minus 2x. We know GH is 39 minus 3x, and we know we are looking for DE. Okay. Do we have any corresponding parts that are congruent, or do we have any measurements for any of our corresponding parts? And we do. Angle E, angle H are congruent, and we both have measurements for those angles. So since angle E is congruent to angle H, we know the measure of angle E is equal to the measure of angle H. We know the measure of angle E is 19 minus x. We know the measure of angle H is 27 minus 2x. So again, without drawing it, you could have figured out just by looking at the name. So if we saw that E and H were congruent, we would have known that angle E is equal to the measure of angle E is equal to the measure of angle H. Add 2x to both sides. 19, we have 19 plus x is 27. Minus 19 from both sides, x is going to be 8. But we're not looking for x, we're looking for DE. Right? Some of you guys are just going to stop there, but you should not stop there. You should read the question and answer what it wants you to answer. It wants us to answer DE, the distance between D and E, the length of DE. Luckily, we know GH, and we know that DE is congruent to, so I'm just going to do it down here. So we know that DE is congruent to FH, or GH, I'm sorry, GH. We know that DE is congruent to GH. So therefore, we know DE is equal to GH. The distance, the lengths are equal. So we know DE is going to equal, if we substitute in, we know GH is 39 minus 3x. We know what x is. We know x is 8. So we can substitute that in. So we're going to have 39 minus 3 times 8. So DE is going to be 39 minus 24, which is going to be equal to 15. So we know that DE is 15. All right, 39 minus, well, again, substitute in 8. 3 times 8 is 24. 39 minus 24 is 15. So if this is 15, we know this one is also 15. We could also find the measure of angle D, for example. So we know x is 8. So we know the measure of angle G is 25. So we know the measure of angle D would be 25. All right, we could find measure of angle C and F. That would be a good problem, right? We'd have to substitute in. If it asks us what was the measure of angle C, right, we'd have to substitute in 8. So we would have 17, or 19 minus 8, which is 11. We know this one's 25, right, because 8 plus 17 x plus 17, so this is also x plus 17, so this is 8 plus 17, which is 25. Then we know these three angles would add up to 180, so we would end up getting an obtuse angle, so we kind of drew our triangle poorly, right? Our triangle really would have looked something like this, because it would have been an obtuse triangle, because this is definitely going to be greater than 90. But they just wanted DE, so that's all we had to do. Okay. Okay, second one. Again, if we look right at the problem, we know R is congruent to X. Angle R is congruent to angle X, so we know the measure of angle R is going to equal the measure of angle X. And then we also know that RT is going to be congruent to XZ. So when we find X, we can then say 7X plus 5 is going to equal XZ. But let's draw it out. So pretend we didn't know that, we would draw it out. RST X Y Z. Again, RS is congruent to XY. ST is congruent to YZ. RT is congruent to XZ. Angle R is congruent to angle X. Angle S is congruent to angle Y. And angle Z is congruent to angle, or angle T is congruent to angle Z. Again, we're getting this from the order of the triangles. So we know angle R is congruent to angle X, which means the measure of angle R is equal to the measure of angle X. Definition of congruence, right? If two angles are congruent, then their angle measures are the same. So we know 11x minus 1 is going to equal 9x plus 5 minus 9x from both sides. 2x minus 1 is 5. Add 1 to both sides. 2x is 6. Divide by 2. X is going to be 3. Okay, but we're not looking for x. We're looking for xz. Okay, so we know RT right here is 7x plus 5. Okay, and we're looking for this number right here. So we know RT is congruent to XZ. Therefore, we know RT is equal to XZ. Okay, RT we said was 7x plus 5. And we can substitute in now our 3. So 7 times 3 plus 5 is XZ. 21 plus 5. So we're going to get 26 as XZ. Okay, so we know XZ is 26. We also know this is 26, right? 7 times 3 plus 5, so 7 times 3 is 21. 21 plus 5 is 26. I'm going to do the next one up here, so I have more room. All right, so I'm going to erase this one and do it up here. Okay, so this is now this problem, this third one down here. So we have triangle, again, we don't need to draw it out. If we notice that K and N are congruent, so measure of angle K is going to equal the measure of angle N, and we can find X. We also know the measure of angle L and the measure of angle O are going to be equal because the angle L is going to be congruent to angle O. Okay, it wants us to find the measure of angle M. So this is going to allow us to find, we got to find X, and then we can find N. Once we find X, we can find what the measure of angle N is, and the measure of angle O. Right, then we're going to have two angles of that triangle, M and O. Then we can add those up and subtract them from 180 to get the measure of angle. Okay, but let's draw it out just so we all know what we're talking about. J, K, L. M, N, O. So again, we know all of this is going to be true because we drew it out in the same order. Okay. So we know angle K is going to be congruent to angle N. Okay, so we know the measure of angle K is going to equal the measure of angle N. So 3x plus 7 is going to equal 2x plus 24. Okay, minus 2x from both sides. I'm going to subtract 2x from both sides. X plus 7 is 24. Subtract 7. X is going to be 17. So let's find the measure of angle N. Okay, so the measure of angle N is equal to, we said 2x plus 24. And now we have also said that x equals 17. So 2 times 17 plus 24. So 2 times 17 is 34. 34 plus 24 is going to give us 58. So the measure of angle N is 58. Okay. We also want to find the measure of angle. So we know this one's 58 degrees. 58 degrees. We want to find the measure of angle O, which we said was 4x, or is 4x minus 25. So 4 times 17 minus 25. Okay, so we know 2 times 17 is 34, so we know 4 times 17 is going to be 68 minus 25. Right, so it's going to take us to 63, 53, 43. So we know the measure of angle O is 43. Okay. And by the triangle sum theorem, these three angles are going to add up to 180. So the measure of angle M plus 43 plus 58 is going to equal 180 degrees. So the measure of angle M plus, this is going to be 61 plus 40, which is 101, is 180. So minus 101, the measure of angle M is going to be 79 degrees. So this one is going to be 79, and that's what we're looking for. All right. Okay, the next one was on the in-class review we did again. It was the exact same problem. So if we don't know what to do, the first thing we should do is draw it out and label our diagram. Okay, so we have they're giving us triangle ABC. So again, we draw a triangle ABC. We know the measure of angle A is x. We know the measure of angle B is 1.5x plus 15. And we know the measure of angle C is 3.5x minus 15. Triangle sum theorem tells us the measure of the three interior angles of a triangle add up to 180. So x plus 1.5x plus 15 plus 3.5x minus 15 equals 180. So these are our three angles. Okay. Combine like terms, x, 1.5x, 3.5x. That's going to give us 2.5x plus 3.5x. Okay, which is like 3 plus 3, which is 6. X plus 15 minus 15. Cancel out. 6x is 180 divided by 6x is going to be 30. Always dropping that cap. All right, here's the last 9. So state the postulate or theorem you would use to prove each pair of triangles congruent. If the triangles cannot be proved congruent, write not possible. So our possibilities are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. If we look at the first one, besides the hash marks and that they're telling us, right, we can also look for shared sides and vertical angles. So in 24, we notice we have a shared side. So let's put our hash marks in for our shared side. Okay, cover up one triangle. All right, so cover up one triangle. We have angle, side, side. Is angle, side, side one of our possibilities? No, it is not. Okay, so we know we can't do that. Okay, but before we say it's not possible, we have to consider hypotenuse leg. So the hypotenuse leg theorem says that we have right triangles with congruent hypotenuses and a pair of congruent legs. Okay. So here we have right triangles because the definition of a right triangle is a triangle with a right angle. So if we have a right angle, we have a right triangle. Okay, we need a pair of congruent legs, which we have, and we need congruent hypotenuses, which we also have by the reflexive property. So we can use hypotenuse leg. Okay, if we don't see it, okay, I'm going to draw a little smaller so I can fit it in here, though. Okay. So I'm going to take these two triangles apart. Imagine pulling them apart. Right, in our triangle, we have a leg, and a hypotenuse. Here we have a leg, and a hypotenuse. The hypotenuse is the longest side. It's the side opposite the right angle. Okay, so if we notice, we have hypotenuses that are congruent. That's this piece right here. They share this piece, and this piece is congruent to itself by the reflexive property or symmetric property, whichever one you want to use. Therefore, these two triangles both have a hypotenuse that is congruent. The hypotenuses are congruent. And then we're given that a pair of legs is congruent. So we can use hypotenuse, leg on this one. Okay, so HL. Next one, again, look for shared sides or vertical angles. We have vertical angles. Okay, cover one triangle up. We have angle, angle, angle. So is angle, angle, angle one of our possibilities? It is not. Okay, let's check for hypotenuse leg though. Do we have any right angles? Nope. Since we don't have right angles, we can't use hypotenuse leg. I mean, one of these may be a right angle, but there's no information that would tell us that it's a right angle, so we can't assume that. So we have angle, 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 which does not work, so not possible. Again, they may be congruent. We just don't have enough information to determine that. Number 26. We have a pair of sides that are congruent. We have right angles. We know right angles are congruent by the right angle theorem that says all right angles are congruent. Okay, and then it's telling us we have another pair of sides that are congruent. So cover up one triangle, side, angle, side. So yeah, side, angle, side. Go in order. Right? If we have these triangles are going to be congruent by the side, angle, side postulate, which says if we have two pairs of sides that are congruent and the included angle is congruent, then the triangles are congruent. 27, again, look for shared sides, vertical angles. So we have vertical angles. Cover up one of the triangles, angle, angle, side. Okay, if you guys wrote side, angle, angle, just flip it around. I mean, I would probably not mark you wrong, but just flip it around so you have angle, angle, side. 28, again, vertical angles. Cover up one of the triangles. Angle, side, angle. What do we have here? We have an angle. What do we have here? We have a side. What do we have here? We have an angle. Go in order. 29, we have reflexive property or symmetric property to tell us that that's congruent. Now we have three parts, right? What we're looking for here are three parts that are congruent. So in each one, we should have three parts, unless we're doing hypotenuse-like. But then again, that we need right angles. So yeah, we're looking for three parts that are going to be congruent in each one. Okay, once you have those three parts, then you cover up one of the triangles and say what we have. So if we have 29, we can't cover this triangle up and look at what we have yet because we only have two corresponding parts that are congruent. We need three corresponding parts that are congruent. So we use the reflexive property to show that here's our third congruent part. Cover up one of the triangles. Is this a side or an angle? It's a side. Is this a side or an angle? It's a side. Is this a side or an angle? It's a side. So it's a side, side, side postulate. Okay. Right now, we have one piece of corresponding parts that are congruent. Okay. We can use reflexive property to find two. A second one, is it possible to find a third corresponding part that's congruent? Nope. All right, we can't assume that this is an angle bisector, therefore we can't assume these are right angles. We can't assume it's perpendicular, so this one is going to be not possible. We could not find a third corresponding part that was congruent. Number 31, right? It's telling us these two are congruent. Well, it's telling us all four are congruent, so we have a square. Okay, so we can know that we have two sets of congruent parts. Okay, again, reflexive. Right now we have two corresponding parts that are congruent. We need a third one. Okay, now that we have a third one, by the reflexive property or symmetric property, depending on how you want to look at it, cover up one of the triangles, and we have, is this a side or an angle? That's a side. Is this a side or an angle? It's a side. Side or angle? Side. Okay. So side, side, side. Postulate tells us that since we have three corresponding sides that are congruent, three pairs of sides that are congruent, the triangles are going to be congruent, which is the side, side, side postulate tells us. Okay, 32, we have a pair of congruent angles and a pair of congruent angles and a pair of congruent sides. If we want to use one of our postulates, we need a third piece to be congruent, and we don't have any. So again, this one is going to, we can't say these are reflexive because they're not together, so we don't know for sure that they're the same length. So we have to say not possible. They very well may be congruent, but we just simply don't have enough information to find that out. So the two ways it's not going to be one of these is if it's angle, 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 or angle, side, side. So if we have angle, 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 or angle, side, side, we know it's not going to work unless the angle, side, side is a right angle. And then instead of using angle, side, side, we're going to use hypotenuse-like because hypotenuse-like will work. It will tell us that we have congruent triangles. Okay, then the other way is we simply do not get like 30 and 32. There's not enough information there to get three corresponding parts that are congruent. If we can't get three corresponding parts that are congruent, we know for sure that the triangles are not going to be. We know for sure that we can't figure out if the triangles are congruent. They may be congruent, but again, we just simply don't have enough information. So this was the review on that went along with the worksheet on the triangle inequality theorem.